In Minecraft, we see stone and other rocks such as deep slate, granite, and diorite, but those last few are what confused us. Those rocks all have names. These are all rocks in the game that have real-world counterparts. Sure, they might not look exactly the same, but they come from reality. So that then begs the question, what is stone? The shortened Google definition is solid, hard mineral matter. Let's see what Minecraft's definition is. Okay, so not very helpful. If we want to be able to identify stone to a real-life rock, we're going to have to ask a different question. What is lava? You see, lava is just molten rock, so if we can identify some key properties of lava, we should know more about the rock it came from and therefore identify what stone is. As I said, lava is any molten rock, and in Minecraft there's actually two types of lava. No, there aren't actually two separate items or different Minecraft IDs, but there is one extremely large distinction, and that's the viscosity. Viscosity is very simply the resistance to flow. For example, water is a liquid with a low viscosity, meaning when poured out, it quickly disperses. Honey, on the other hand, has a very high viscosity, meaning it does resist flow. Hence why when poured out, it barely moves. We can very clearly see that these two lavas do not behave the same. One of them flows further, faster, and thinner, whereas the other one flows shorter, slower, and thicker. The reason behind the different viscosities is due to its composition, another word for what it's made out of. Before we use both the composition and viscosity of lava to identify the rock, we are going to have to do a deeper dive on some basic geology. Earth is made out of elements, specifically these 5, and as you can see, 75% of the Earth's mass is just oxygen and silicon. So the different amounts of elements make up different compositions, ranging from the categories of felsic to mafic. Felsic means high in silica but low in iron, and mafic's the opposite, meaning lower amounts of silica but higher amounts of iron. A felsic lava is going to have a higher viscosity, meaning it flows slower. A mafic lava has a lower viscosity, which means it's going to flow faster. This is also what we see in Minecraft. 2 different lavas with 2 different compositions flowing at 2 different speeds. Okay, we're getting closer. So let's look at some examples of rocks. Here are the 6 most common examples: granite, rhyolite, diorite, andesite, gabbro, and basalt. If you're interested in geology, you probably know these as the igneous rocks. If you're interested in Minecraft, you probably only know these 4 as building blocks. These rocks all fall on the scale somewhere between felsic and mafic. Rhyolite and granite fall to the felsic side, and basalt and gabbro fall to the mafic side. Diorite and andesite fall somewhere in the middle in a category called intermediate, but we can just lump these towards the felsic side. So there we have it. Stone has to be one of these 6 then, right? We know that stone has to be an igneous rock because it comes from the cooling of lava. Additionally, we know that felsic lavas have a high viscosity, meaning it can't be basalt or gabbro, but rather one of these 4. Okay, here's the moment you've all been waiting for. We know that stone isn't granite or diorite or andesite because they're already in the game, which leaves just one contestant for stone left. Ladies and gentlemen, for the first time ever, Minecraft stone is Rhyolite. It's actually a perfect match. If you compare real-life rhyolite to the properties of stone, we can even further assure we identified it correctly. Here's what we know. Number 1, the color and texture of stone and rhyolite is visually identical. They both have a fine-grained texture as well as a pale gray color. Number 2, we also know molten rhyolite flows very slowly, much like overworld lava due to its felsic composition. Number 3, like other rocks we know in Minecraft, it's igneous, meaning it came from the cooling of lava. And lastly, number 4, it doesn't already exist in the game, so no issue there. And as I just said, the texture is fine-grained, meaning you can't make out the little individual pieces unlike granite and diorite, which cooled slowly underground. Rhyolite cools on the surface. And in Minecraft, what rock's on the surface? That's right, stone. But there's one more thing that makes stone undeniably rhyolite, a fact that can't be disputed, a fact that triumphs all science done up to this point. Rhyolite is literally obsidian. Look it up. Basically, the only difference is how fast it cools. It all comes from the same stuff. Obsidian is just rhyolitic lava that is cooled so fast it forms volcanic glass. Just another word for obsidian. And what happens in Minecraft when you rapidly cool lava? That's right, it turns to obsidian. So we know that obsidian, overworld lava, and stone are all the same stuff. So for God's sakes, the only possible conclusion to draw from this video is that Minecraft stone is rhyolite. But hold on a minute, I'm not done. Remember, we had 2 lavas, one felsic and one mafic. The felsic lava turned out to be rhyolite, so then the nether lava must be one of the 2 mafic rocks. Sure enough, if we use the same logic as before and cool the lava, we get basalt. Whoa, but isn't basalt already in the game? Hush, we're getting there. Basalt is a fine-grained rock, meaning it cooled quickly as we just saw. And also, it's mafic, which means the lava flows fast, much like the nether lava does. Wait, but then what is netherrack, I hear you thinking? Wouldn't you assume that if overworld lava was stone, that the nether lava should be from netherrack? You might not like this answer, but I am also going to identify netherrack as basalt, just slightly different. Generally, basalt should be black. However, this looks pretty red to me. But what is the nickname for Mars? The red planet. And guess what the surface of Mars is made out of? That's right, basalt. Because it's mafic and rich in iron, that means it can rust, which gives it that ugly reddish color. So I guess a more fitting name for netherrack would be oxidized block of basalt. But wait, there are so many other versions of stone in the game, such as Blackstone, Endstone, Dripstone, and even Glowstone. So let's do a quick speed around and try the best to identify the following rocks. Starting off with Blackstone. This one should be relatively simple. We know that it's found in the nether in patches underground, with the exceptions of basalt deltas, and share many properties with magma blocks. That's because magma and Blackstone can both be identified as the same rock. Right off the bat, I'm just going to tell you, it's gabbro. This was the only one of the 6 main igneous rocks we looked at that didn't yet have its Minecraft counterpart. Basalt came from the cooling of lava, which is a fast process. Gabbro comes from the cooling of magma, which is just lava when it's underground. Because magma cools slower, it allows for more crystals to grow, giving a coarse grained texture. Let's move on to Dripstone. In Minecraft, we see these blocks in their own cave biome, which very closely mimic a limestone cave. These are famous for their stalagmites and stalactites, or to put it in Minecraft terms, they're pointed dripstones and pointed dripstones. These spikes are made from when water-rich and dissolved minerals fall from the ceilings, leaving behind mainly calcite, which is the mineral that we already have in-game, and also the main component of limestone, which makes dripstone limestone and pointed dripstone also limestone? Kinda calcite? Moving on. Endstone, the block that's just an inverted yellow version of cobblestone, is actually not real. Grow up. Sure, we could go based off its blast resistance and color, but that's not nearly enough properties for me to discernibly identify it. Glowstone, on the other hand, does have something I can work with. There is one very special mineral with the property called reversible photochromism, which gives a mineral the ability to change color or even glow in the presence of UV light. The mineral that I'm talking about is called hackmanite, which happens to be very similar chemically to the mineral lapis lazuli. Obviously, the main issue with this identification is that it only gives off a light level of 3, and I'm just kidding. The real reason is that it doesn't naturally stay lit, and obviously, much like Endstone, is a fictional dimensional block that can exist in the real world, but, it was worth a try. As a little bonus round, I'll identify the rock Tough. It's tough. It's already in the game. If you have any complaints or issues with the science done here, I will have you know I attended 8 years of college in pursuit of a doctorate in art history, and I never did make it to sophomore year, but anyways, I clearly am an authority figure on this matter and should be trusted with complete confidence. One more interesting fun fact to leave you with. Calcite, the block found in geodes, isn't actually a rock, but rather a mineral. Calcite comes from dead marine organisms depositing at the bottom of the ocean and compacted over time under intense pressure. Marine organisms, such as plankton. That's right, we already have plankton, sponges, and squids in Minecraft. Next update, expect to see crabs, starfish, and pineapples. Thank you, I'm done.